Good evening, ma'am.
Good evening, everyone.
Good evening, ma'am.
Good evening.
Good evening, ma'am. Good evening, ma'am.
Good evening. Good evening.
Good evening, ma'am.
Good evening. Very good evening. Okay, so let's begin now.
Good evening, ma'am.
Very good evening, all of you. Okay. Quick recapitulation. Hmm. Divesh, tell me the types of motion.
Okay, ma'am. From the types of motions are rectilinear motion, circular motion, periodic motion, curvilinear motion, and auxiliary motion.
Okay. Ashwath, are periodic and oscillatory motion same?
No, ma'am, they are not same.
No, ma'am.
What's the difference?
Ma'am, if the movement is to and fro, it is called oscillatory motion. And if the motion is like it repeats at a particular intervals of time, it is called periodic motion.
Okay. Adrit, state examples of rectilinear, curvilinear, and circular motion.
Ma'am, can you repeat?
State examples for rectilinear, curvilinear, and circular motion.
Ma'am, ma'am, in rectilinear, ma'am, ball rolling.
Ball rolling on the ground is rectilinear.
Yes, ma'am.
No, ma'am.
Rectilinear, I guess one more type of motion can be is present there.
Ma'am, can I tell the examples?
Let Adrit only speak, please. Okay, Adrit, anyways, tell me for curvilinear and circular.
Circular ma'am, a table fan.
Sorry,
Ma'am, in circular motion, it's table fan.
table fan, circular motion. Okay,
Ma'am, and for
curvilinear,
ma'am,
Advika.
Ma'am, can I say?
No, Advika.
yes, ma'am.
Rectilinear and curvilinear. Quickly, please be quick. We need to move ahead as well.
Ma'am, can I tell?
Okay, Sritij.
Ma'am, for curvilinear, a snake, and for rectilinear, you can take a bicycle and march past. And for circular, the wheel of a moving bicycle. And for periodic, a sewing needle of a sewing machine.
Great,
And
great,
oscillatory pendulum.
great, good. Rishit, how speed is related to distance and time? Be very quick.
Speed is directly proportional to distance.
Okay, and for time?
It's like indirectly like proportional.
Okay,
Inversely from
inversely with time. Yeah, correct. Aishwarya, formula for speed and its standard unit.
Ma'am, speed equals distance by time, and standard unit is S.
Standard unit is S for speed. What is S? S stands for?
Speed.
No, dear. S
Ma'am,
stands for
seconds it stands.
Ma'am,
Smallest
wait,
is
wait. Not like that. Charvik.
can I see? Per
Charvik
second.
Anup. Charvik Anup. Seventh class, I told you I want everyone to participate in discussion. It's fine if you don't know the answer or if you speak up wrong. That's totally fine. So please speak up and unmute and speak up. Charvik Anup, tell me the unit, standard unit for uh, speed, quickly. Sriyansh,
Yes, ma'am.
same question. Unit for speed.
Could you repeat it? Your voice is a little low.
Tell me the unit of speed, standard unit of speed.
Meters and kilometers. Wait, no, that's distance.
Dear, for speed, I'm asking. Speed, not distance.
Speed.
The formula of speed is distance upon time. You can make the unit directly from its formula. Distance per unit time.
Distance divided by time.
Yeah. So SI unit of distance is meter and for time is second. So according to formula, it becomes meter per second.
Okay,
Isn't that simple?
that's fine.
Okay, meter per second is the standard unit, and other units can be, kilometer per minute, kilometer per second, kilometer per hour, or it can be centimeter per second. Means any combination of, any unit of distance with any unit of time can be there. But the standard one, which is accepted worldwide, is meter per second. Okay.
Ma'am, like in some countries, it is like mile per hour or something.
Yeah, miles, because the miles also is the unit of distance. Okay, now let me share the whiteboard. Hold on.
Ma'am, 1 mile means how many kilometers or how many meters is it?
7 kilometers something. No, wait. 1 miles. 1.4 kilometers something is 1 miles.
Ma'am, I think 1,200 meter.
1,002. I guess 1.4 as I know it. Not exactly.
Ma'am, so 1,400 meters.
Near to means it is about 1.5. That I'm sure.
Ma'am, it is 1.6 kilometers.
1.6 kilometer. Are you sure?
Yes, ma'am.
Okay. I'm sharing the whiteboard because we need to learn more about periodic motion, the pendulum concept and its frequency and time period and etc. A lot of that. Okay. Be careful, be attentive, everyone.
Okay, ma'am.
Whiteboard visible.
Yes, ma'am.
So yesterday we were discussing the types of motion, where one of the motion is oscillatory motion. Okay. Oscillatory, by this word we mean the motion in which an object moves to and fro about a fixed position. I'm not writing the complete sentence, please understand. And a very good example of this is a swing or a pendulum. Okay. This metallic part is known as a bob, means in clock it can be metallic or non-metallic, but ideally it should be metallic and it has specific dimensions also. Now, okay, what is the concept of pendulum? Suppose this is not in motion right now. This is the position of rest. It is resting and not in motion. If we displace this bob to a point here, let I name it A. If I just displace it up to this distance, okay, it will gain energy because I used up my energy and I displaced it to point A. So this bob has gained energy now. And after releasing, what will happen? That it will move from the rest position and will reach the opposite point, and that will be almost at the same distance as that of point A. Means the distance of point A and B, if we measure it like this, the shortest distance between, I'm naming the rest position as O. The distance of OA to OB are ideally should be same. Okay, means this bob is expected or supposed to make the to and fro motion in between these A and B points and passing through O each time, right? So basically, very simple. If you know what is mechanical energy, anyone knows what is mechanical energy? This is actually the combination of kinetic and potential energy. I'm telling you in very short, again, this is not in grade 7. I'm just telling you something apart from this grade 7. Mechanical energy means when something is in motion, we call it, possessing mechanical energy. This is actually the combination of kinetic plus potential. Now, not necessarily every moving object will have kinetic or every moving object will have potential. It can be either kinetic or totally potential or totally kinetic. Kinetic is when anything is pursuing motion, that possesses kinetic. And if there is just the change of position, mainly vertically, means above the surface of Earth, change in position vertically is said to possess potential motion. Position, I should say, the change in position. It can be horizontally also. Okay, let me give example. A child running on the road possess kinetic energy, and a stretched rubber band possess potential energy, where both of these have mechanical energy. Did you understand?
Yes, ma'am.
Can you repeat that example for the kinetic and potential?
A child running on the road or jogging in the park possess kinetic energy, whereas a stretched rubber band is possess potential energy because there is a change in position, and because we have used up our energy and we have made it stretch to a certain limit, which is the limit of that rubber band only. What will happen if we release it? The energy stored in the stretched rubber band can be seen when we release it. Where it will be seen? It will come back to its original position. This is the using up of energy of the stretched rubber band. Because one statement, remember that energy is neither created nor destroyed, it only gets transformed. So we should know where and how our energy is getting transformed, right? Okay, anyways, this was something extra, that's fine. Main thing
Ma'am,
is, yes,
and potential energy, is it compulsory for the, for the object to reach to its original position?
no, this was just one example. Wait, suppose I'm carrying my suitcase and I take it to 5th floor. to 5th floor. Now, if I release it from the 5th floor, what will happen? It will come back to the ground. So because of change in position, the potential energy again got stored in that suitcase. Because it was not at the ground level, it got to certain height.
Okay, ma'am.
Fine. Well, to and fro motion if Bob is making now A through O, then B. Through O to A, through O to B. And this keeps on taking place. Okay, to and fro motion. Now, how many, if we just take, 1 second of time, Rishad, I'll just listen to your question. Give me a minute, let me complete this. If we just at 1 second of time and I am counting its one oscillation, let's say my oscillation starts at A. Listen carefully. Now, how one oscillation is counted? A through O to B and back to A. Means from where we are beginning the journey, it should end at the same point. Then it is counted one oscillation. Now, suppose I want to count it from rest position O. I displaced it to A. Okay, this is the first movement to A, then back to B, and then to O. If I start from O, then this is my one oscillation. This is my one oscillation. This is again my one of oscillation. And if I started counting from B, then B to A, and then again back to B is my one oscillation. I hope from any point if you count, you can, you are well familiar how to count one oscillation or one cycle, anything. Okay. Now this is pendulum because we have seen in the clocks that, it moves quite slowly. But if the pendulum moves so fast, then might be possible that in 1 second it is taking 4 oscillations. Okay. Let's say 1 second, 4 oscillation. Then this 4 oscillation is the frequency of this motion. So basically we can say frequency of motion is the number of oscillations per unit time or in 1 second. Is it okay?
Yes.
And on other hand, please be attentive here only. 1 second, 4 oscillations. Now I want to see that it means how much time one oscillation is taking to complete. Very simple. Instead of 4, I want to know the time of one oscillation. That will be equal to 1 upon 4 seconds. Isn't
Need
it?
to convert to smaller unit.
Then your voice is cracking. Pardon, please.
Ma'am, one oscillation.
Yeah. So I'm writing here one oscillation will be completed in 1 by 4 seconds, means 0.25 seconds. Okay.
Yes, sir.
So this is
Yes, ma'am.
the time
Ma'am,
period.
25 minutes.
So basically, what is time period? Time taken by one oscillation to complete is time period.
Okay, ma'am.
Okay. You can note it down quickly, please.
Ma'am, can I ask my
Yeah.
doubt?
Ma'am,
Yeah, yeah, yes, yes.
Ma'am, there are something like Newton's cradles, right? Like
Pardon?
Newton's cradles, like there are kind of these pendulums, like I think 5 or 6. But like in that, if we pull one pendulum to the A, and if we release it, it goes to O, and the last one will go to like B.
Okay, okay, you're talking about which has like 4 to 5 bobs and
Yeah, ma'am.
we
Yeah,
are
ma'am.
using 2, then if we release it, then at the on the other side also 2 will, okay. The concept is not, that concept is different here. The concept is that of momentum. Have you heard this
Okay.
word earlier? Momentum.
The momentum of an object.
Momentum of an object, yeah. That
And
concept is
what does it
different.
mean?
It is not about, this oscillatory motion. That is something different.
Okay.
ma'am, what happens to O oscillation?
It happens to
O, the oscillation. If you keep it like started from like O.
it is there. If we start at O and we make it to the position, reach the position A, if and release it from A, it will pass through O again and reach B, give a pause for a fraction of second, and then will come back to O. Means this motion will keeps on taking, it will keep on repeating itself. But I told you here that if you start from A, if you start from O, or if you start from B, then means up to what level one oscillation to be counted.
Like as of my knowledge, as of my knowledge, momentum is a quantity of motion of a moving object, right?
Right, correct.
And so, isn't it related to motion?
Dear, no. That concept is totally different in grade 9. That is of grade 9. Okay. Now, if
Does it consider like momentum of inertia?
dear, you are correct. These are the topics of class 9. Now, if you want to take them here only, then we have to move away from this motion and time and whatever we are now learning.
Like my question was it related to motion?
No, related to motion, but not it is oscillatory or it is periodic, not with the type of motion. Definitely, momentum is related to motion.
Okay.
Have you noted this? All we need to practice questions also.
Wait, the sewing needle of ma'am.
Hmm?
Does the sewing needle of a sewing machine show the mechanical energy?
Yes.
It is also showing oscillatory energy.
Yes. Mechanical
So,
is
like,
the energy and that oscillatory is a type of motion because it has motion also when we are sewing the cloth actually, and it has potential also because it keeps on changing its position up and down, up and down.
okay, ma'am.
Hmm.
So, like, does it have a position at rest?
Yeah, it has. When it is at rest, when we are not sewing it, it has some stationary position.
Okay, ma'am.
Now, please note down the question. A simple pendulum takes 32 seconds. I'm writing only the required part that is given. You please listen carefully. A simple pendulum takes 32 seconds to complete 20 oscillations. Okay. What is the pendulum's time period? Find it out. A simple pendulum takes 32 seconds to complete 20 oscillations. Find out the time period. How we can find the time period?
Ma'am, time taken and number of oscillations.
Yes, total time taken. By this concept only, you can see that on the top, we should have, how much time is total taken, 32 seconds divided by number of oscillation is 20. Please calculate and tell me.
Like it
Is
is
there any like formula?
1.6 seconds.
Ma'am, 1.6.
Ma'am, 1.6 seconds. Ma'am, is there any formula?
Here you can derive the formula, although the concept is like these two methods that I have written now, these are called methods. Okay. But okay, that's fine. If you want formula also, we can write for time period, capital T denotes your time period. That will be total time taken, whatever time is given to you, divided by.
Ma'am, what's the formula to find oscillators?
Just a second. This is the formula for time taken.
Okay,
Now,
ma'am.
for frequency, you can say, look at the formula here. Frequency is simple. It will be inverse, means number of oscillations, total number of oscillations given to you divided by total time taken. Because when you divide by total time, you will get, number of oscillations per unit time. This becomes the formula now.
Okay, ma'am.
For this question, tell me frequency also. Tell me frequency also. Number of oscillations, 20. Total time taken, 32. Get the answer, please.
Ma'am, 0.625.
0.6. Are you sure?
0.625.
Okay. Fine.
Like,
This
can
frequency
we,
is the count
like,
of oscillation, so no units, and time period is the time of oscillation, so there's a second. Okay. I hope you got the
like, is there any unit to for frequency? Like a
no,
hertz, like
wait,
hertz.
telling you be attentive, please. I just told you frequency means number of oscillations per unit time. It is just a count of oscillations, so no unit.
Okay.
Okay. Is it clear?
Yes, ma'am.
Okay. Just a minute. Should I clear the annotation?
Yes, ma'am. No, ma'am, 1 second.
Speak with.
Ma'am, so like basically what is the exact definition for time period?
Okay. Everyone, please note down now. Time period is the time taken by one oscillation to complete. Time period is the time
Can
taken
you repeat?
by one oscillation to complete, and frequency is the number of oscillations per unit time. Frequency is the number of oscillations per unit time.
Ma'am, can you repeat for time period?
Ma'am, can you also repeat for frequency?
Frequency is the number of oscillations per unit time.
Ma'am, time period.
Time period is the time taken by one oscillation to complete. Done now, should I clear it?
Ma'am, I have a doubt.
Hmm.
Like, my doubt is the bob of a simple pendulum is set in a motion, and in the beginning, its time period of 1 second, and after 30 oscillations, the bob appears to be slowed down. And what will be the time of one complete oscillation? Like, what will the time of
Can you
one
please
complete oscillation?
repeat? Wait, can you please repeat your question?
Ma'am, I will send in the chart.
Okay. I'm clearing the annotation, okay?
Ma'am, I sent in the chat.
Okay, just a second. Let me first write the question for all of you so that you can start doing it. Okay, listen to the question carefully. A man runs at the speed of 10 km per hour. A man runs at the speed of 10 km per hour. How much time will he take to cover 750 meters? Got the question? A man runs at the speed of 10 kilometer per hour, how much time will he take to cover 750 meters?
Ma'am, 75 kilometer.
Yes,
75.
ma'am, 75 seconds.
75.
75
75 seconds.
75 seconds.
kilometers. Is it kilometer?
No, ma'am, seconds.
75 seconds.
75 seconds. Okay.
Ma'am,
Tell me the
1
formula
minute
for time
15
quickly.
seconds.
Although I have not got the answer from everyone. Formula for time would be
Distance by speed.
By speed.
Distance by speed.
okay. So you have converted everything into meter terms only. Speed is 10. So should I convert this 10 into some other unit? It is kilometer per hour.
Second.
Second. For second, in place of hour, I should have meter also here in place of kilometer. What should I do with this 10 now? Tell me.
Ma'am, we should convert into meter.
Yes.
Tell me what to do.
Ma'am, after 10, 3 zeros.
After 10, multiply or addition or divide or what?
Multiply with 1000.
Multiply.
Multiply with 1000.
Okay, so that divide part I am taking directly in numerator. Divide with what? 1 hour is how many seconds?
60.
60.
1 hour is 60 seconds.
360.
3600.
3600 seconds.
Good. Now calculate. Is it still coming out to be what you told me? 750 seconds, right? Something like that. If I cancel,
Ma'am, I didn't understand why I'm multiplying by 1000 and like 3.
so as to convert my speed from 10 kilometer per hour to meter per second.
Okay.
Because I have the meter and I have to tell the time in seconds. So everything should be in meter and second terms.
Okay.
Now convert and tell me, because in earlier you all were telling the answer is 750.
Ma'am, 270.
How much it is?
270.
70. Is everyone getting the same answer?
270.
27?
270.
Okay,
270.
it's much seconds. So please, first of all, read the question carefully. Look at the units. Because many a times, we need conversion from one to other unit and then tell the answer. I was also shocked, how quickly everyone is telling 750 seconds. 75 or 750 something you people are telling. So got the concept, everyone? Any doubt? Any doubt?
No, ma'am.
Okay, next question. Next question again. Now be careful. Solve and then answer. A cyclist travels at a speed of 20 km per hour. A cyclist travels at a speed of 20 km per hour. How far will he travel in 50 minutes? How far will he travel in 50 minutes? The time given is 50 minutes. The formula for distance is
Speed into time.
Speed into time.
now. So because kilometer, hour, and minutes, we have three different units here. Let's take them to the single standard unit, that is seconds only. Okay. So speed equal 20 into, solve and then tell me. 20 into what should I write?
50.
50?
Ma'am, 60.
15 to 60. 50 minutes is converted into seconds now by multiplying with 60. What about 20?
Ma'am, 20 is being multiplied by 3000.
Only 3000. I have 20 kilometer per
30
hour.
to 20 kilometers, 3,600.
Kilometer 1000 and divided by R. R is in denominator. So 1 hour is 3600 seconds.
600.
Now solve this complete expression. Simplify and find the answer.
Ma'am,
Yeah.
it's like 20 by 60 to 50 minutes, right?
Pardon, your voice was cracking.
Ma'am, isn't it like 20 kilometer by 60 minutes into 50 minutes, right?
No, why 16 divide here? It's very simple. Why you are getting confused? Hold on. This formula, up to this formula, is it fine?
Yes, ma'am. Yes, ma'am.
Okay. Now speed, the value of speed is 20. And can you see it is in kilometer per hour? So conversion from kilometer to meter is 1 kilometer is 1000 meter. And 1 hour is how many seconds? 60 into 60. Were you present yesterday? I hope yes.
Yes,
So you should know it. I told you yesterday only. This kilometer per hour has been converted to meter per seconds by multiplying with 1000 by 3600. Okay. And now in the formula, I have time here. The value of time given is 50 minutes. 1 minute is how many seconds?
60 seconds.
Yeah, so that's why this is. Okay. Now time also is in seconds. So second cancel. Whatever value you will be getting. Solve and then tell me. I'm waiting for the answer, everyone.
Ma'am, is the answer like 16 point, like 17 kilometers?
How much?
I got 166.66.
It should be something in decimal only because
Ma'am, 17 kilometers, like 1.6, like 1666.5 meters. So in kilometer it will be 116.67, that is 17.
Ma'am, I got 166.66 marks.
am I right?
1.5 meters.
Is the value correct? Have I written correct? Please let me know.
Yes, ma'am.
Okay, this much meter is the answer. Any doubt in unit conversion?
In kilometer it will be 17 kilometer approximately. And in decimals it is 16.67 kilometers. It's approx 17.
If in question we are already given find the answer in kilometer per meter to this kilometer, then definitely we'll have to choose that particular. But if nothing is given, it's better to convert
Ma'am, your
everything.
voice is low.
I'm telling if in question it is given that take answer in kilometer, meter per second, or minute, etc. Then we will have to take that particular. But otherwise, standard units is only the correct way. Okay, should I stop sharing now?
Yes, ma'am.
Fine.
Ma'am, can you answer my doubt? I sent in the chat.
Okay, okay. The ball of simple pendulum is set in motion to and fro. The beginning is time period of 1 second. After 30 oscillations, the appears to have slowed down the beginning time period of oscillation. Okay. Okay, so actually, if we look at the word scientifically, so we manually say idolation to this, idolation to that. But practically, it's not possible. Your question, let me give you an example. Your question is like,
Your voice is
Your voice
very
is a
low.
little bit low.
Ma'am, your
Yeah,
voice is
your
very
voice
low.
is too low.
just a second. Am I audible now?
Yes, ma'am.
Yes, ma'am.
Yeah. So, Siddhant, your question is very similar to the thing. Like, suppose you spill the water on the floor. Okay. It means we have reduced the friction to zero. So, nothing is expected to stop now because we have reduced it to zero value, let's say. Now, if I roll the ball on the ground, it should keep moving and it should keep moving only. But practically, will this happen?
No, ma'am. It will stop at one period.
Yeah, because we cannot ideally, reduce the friction to zero. Some value will definitely be there practically. So this question is like that only. The time of one oscillation would change because we can control the motion of pendulum. You cannot create perfect vacuum. Air is always present inside the room, and due to air resistance, the motion of top will slow down and it will come to less number of oscillations per unit time. So yes, it's if we calculate time period, then it will move because it is slowing down. So gradually, it will be greater than the value earlier. So Dan, is it clear?
Like I didn't understand.
Here I'm telling because yes, the bob will slow down after a certain span of time because it is now taking less number of oscillations, so time period would gradually increase.
Okay, ma'am.
Hmm. You have a test tomorrow. Please revise the syllabus properly and best of luck.
Bye, ma'am. Thank you.
We'll do next year.
Thank you, ma'am.